Very good morning, my dear students, friends. Today we are going to see about the strength of material course in the topic of the main classification of beams and frames. The case of a beam is mainly classified as determinate beams and indeterminate beams. What is called as determinate beams? So in the case of a beam, it will have a support and loading condition will be there. And in the case of finding the equation of equilibrium, you know that there are three equilibrium of equation. The first one is sigma fx is equal to 0, or you can call it as sigma h is equal to 0, where sigma fx is the algebraic summation of all the horizontal forces are equal to 0. Similarly, if you are going for the second equation, sigma f suffix y is equal to 0 or sigma v equal to 0, where sigma fy or capital V is equal to the algebraic summation of all the vertical forces are equal to 0, and the summation of the moments at any point in a beam is equal to 0, that is sigma m suffix x equal to 0 or sigma m is equal to 0, where m is the moment or the couple where we are going to find the beam at a given section. So from that, definitely you can arrive the unknown constraint or the reactions from the beam. If the number of unknown reactions or the constraint which is less than or equal to the equilibrium equations, then it is called as determinate beams. The example for the determinate beams are cantilever beam, simply supported beam, overhanging beam, either it is singly or doubly overhanging beam. And the loading may be of the constant load, inclined load, then UDL, UVL, uniformly varying load, which is called as UVL, or the combination of all these types. You can able to find the unknown reactions, because the number of equilibrium equations, it is capital E, we can call it as, right, which is having a mode, and the number of constraint or reaction is less than, it is called as a determinate beam. But in the case of the second type, which is called as indeterminate beam. So what is called as an indeterminate beam? If the number of constraints or the unknown reactions are greater than the equilibrium equations available. For example, the unknown reactions are 6 and the equilibrium equations available is only 3. So the number of unknown reaction is 6 minus 3, that is equal to 3. So these unknown reaction 3 are the constraint which can be determined by using the various end conditions of the beam. That is boundary condition, you have to use it. For example, if you are taking as a fixed beam and it consists of an inclined load, UDL, constant load, etc. combination, so it will have the unknown reactions is equal to 3 plus 3, that is equal to 6, but the equilibrium equations available is only 3. The unknown reaction is 3. So these unknown reactions can be determined by using the boundary condition. For example, in the case of fixed beam, at the fixed end, right, both the deflection and the slope are equal to 0. That is, y is equal to 0 and theta is equal to 0 at the support condition A and B. So from this known condition or boundary condition, you can able to find the 3 unknowns. The other 3 unknowns can be determined from the equilibrium equation, that is sigma v equal to 0, sigma h equal to 0 and sigma m equal to 0. So the example for the indeterminate beams are propped cantilever beam, the first one. The second one is continuous beam. Third one is a fixed beam. And you can go for the continuous beam with a fixed end at one end and number of reactions. Just for example, is a 5-span continuous beam. That means the left end or the right end should be a fixed one, and the other supports are the either roller support or the hinge support. So from this we can able to find the number of unknown reactions in the case of indeterminate beams. So this is about the determinate and indeterminate beams. And after that we'll go for what is called a section modulus. So that is also coming in the case of a bending of beam or the bending stress in the case of beam. The section modulus, capital Z, is defined as the ratio of the amount of inertia about the neutral axis to the maximum fiber distance from the neutral axis. For example, for a rectangular beam which is of dimension breadth B and depth D, so here using I is equal to Ixx, so that is equal to B dq by 12, and the maximum fiber distance Ymax is equal to here D by 2. So if you are putting the ratio, right, I divided by Ymax, that is B dq by 12 divided by D by 2, you will get B D square by 6. So that is the unit of the section modulus for a rectangular beam is BD square by 6, that is in terms of either cubic meter or centimeter cube or millimeter cube. If you are taking the solid circular beam which is of diameter capital D, so in that case the section modulus of the beam is Z is equal to the I divided by Y max. The I value for the circular beam is pi into capital D power 4 by 64 divided by capital D by 2. So that means we are getting the equation of pi into capital D cube by 32. So that is the section modulus for the circular cross section of the beam. So like that, either hollow circular section or the square section or hollow circular beam can be determined by using the section modulus definition, that is which is called as ratio of the I divided by Y max, where I is the moment of inertia about the neutral axis, Y max is the maximum fiber distance from the neutral axis. So it is symmetrical. If you are taking a rectangular beam, it is symmetrical about the horizontal and vertical axis. That's why the Ixx will be of B D cube by 12 and Iyy will be of dB cube by 12. So from this way you can able to find the section modulus for any given section of the beam. Thank you very much for patient listening, and we can see in the next video of mine, which is called as next topic, the polar modulus and polar moment of inertia. Thank you very much for patient listening, and வாழ்க வையகம், வாழ்க வளமுடன்.